So as we start our afternoon session, I wanted to first just finish up and show you some of the other things that PerfExplorer can do. Just to recap, we started this tool by first going to the demo data tau directory in AWS, deleting the full .paraprof folder, doing an upload.sh, launching PerfExplorer, and with the PerfExplorer launched, you can then see over here that you can expand this H2 database, application, NAS, and then select the scaling, and then you can go to charts and then open these charts. So you could get some chart like a stacked bar chart that shows you what each of these code regions are doing across multiple core counts like this. Here you can always say save as, and then you can specify different types of files with the PNG files and such. And you can also look at different kinds of analysis tasks that this provides. So if I open up, say, 16 node over here, and I click this green ball, which says time, and then I go to analysis and say, select clustering method, or do clustering or inclusive clustering. Now remember, we have exclusive time and inclusive time. So if you want to do clustering analysis, you can choose either exclusive, which is the default, or you can choose inclusive clustering as the other option. So the same thing with correlation analysis or inclusive correlation analysis. So this is with exclusive time, this is with inclusive time. That's the only difference. So if I do, say, clustering, and what am I doing the clustering on? I'm choosing time, all the events, and then within this 16 core profile, I'll click on this and say, do clustering, and then click here. And it says, this is the k-means clustering, max clusters 10, do the analysis. I say, yes, do the analysis. Now it queues it and it's doing the analysis, and you can see some of the console output where it's doing the clustering analysis here in the console. So it says done clustering. So once it says done clustering, you can then click on the analysis tabs here and see the cluster results. And here is the k-means clustering with 2 nodes, 3 nodes, 4, 5, and all the way, and see exactly how these different processors fall into one of these clusters. So starting from 1 all the way to 64 threads of execution, you'll see these as 8 by 8 matrix, and how it would look if you had just k equals 3 versus k equals 10 or and such. So it's essentially saying that if I have 64 ranks, and if I had to pick only 3 colors that I could color each rank with, what would I color this rank versus that rank? Okay, so all the 64 have now been colored this way with 3 colors, with 2 colors like this, rank 0, 1, 2, 3, all the way to the MPI threads. Total threads are 64, 16 times 4. And so you can see all the clustering results over here. There are other visualizations that you should... This is in terms of timing. Yeah, for the k-means clustering for that particular. So here you can look at create histograms. And then you can see these histograms for that event. So which ones are significant? And you can see a number of analysis tools over here. This is 3D correlation cube. There's a data summary tool. And You can see here all the raw data that it has. So you can see the information about the events, exclusive time, exclusive percentage, calls per event. So here is another analysis that we can do. Instead of clustering analysis, oh, wait a minute. I just did an exit, sorry. PerfExplorer. And I can expand this. And open this, go to time. I can look at analysis. And then I can do clustering analysis. So this is the k-means clustering. Or I can do analysis with correlation analysis. And it says, yes, do the analysis. And it queues it up. You'll see all the analysis for every 2 events. So what do I mean by this correlation analysis? If I have 100 different events and I take pairwise events and I say, I want to see how these 2 events are correlated to each other. You know, in supermarkets, they do this kind of analysis when they decide which items to put on sale, right? If there are 2 items that are bought together a lot, then they will put one on sale one week and another on sale the next week, but they won't put both of them on sale the same week, and they can increase their profits, right? So the same correlation analysis, if you look at with events on a parallel profile, then you can see what kind of events you get. Now you have 108 events over here, and it's going to do this analysis for 108 of these. Now, what if you could say, I want to filter out those events that don't matter much? So I can do dimension reduction. So I can say, I only need to look at events that take at least 1% of total time. If it's less than 1% of the total time, just get rid of it. And that number of events of 108 might decrease to something like 32. And then you might be just focusing on those 32 events instead of looking at all the 108 events. What you're trying to find out are there events that are negatively correlated? Like if one increases, the other gets affected the wrong way and it decreases. And so you are doing this by brute force. You're just looking at drawing 2 different charts, 2 different axes, event A, event B. And if you normalize it to 0 to 1 on both of those scales, then each rank has a unique value. If 0 to 1 represents 0 to, say, 100 seconds, which was the max time, and a particular thread takes 87 seconds, then it will be at 0.87 of that 0 to 1 scale. And at that point, you will see what the value for the other event is, and you'll put a red dot where that particular rank goes. And so you're now trying to do this for all the events and getting a good correlation result. And you can see this will take some time to finish, but the results will be available in the cluster results tab over here. And you can already see the cluster, and then there'll be a correlation results tab over here where you can see some events already. So if I see this event, it says the correlation result is 0.82 between copy Y face and MPI barrier. So I would request you to open this to the green dot over here and then click either analysis with the clustering or correlation analysis and look at the cluster results or correlation results. And also look at other visualizations that you can create whether it is the box chart or the histogram, normal probability chart, and you'll see a wealth of information for data mining or a knowledge extraction with just the performance data that's available here. And you can see the quantiles and how many threads fall in that for that particular value for that event. So there is a number of these interesting charts that are canned and available to you for analysis of your performance data results with PerfExplorer. Yes.
So we want to do clustering analysis to go into the trial value type.
Yeah, you go to that green dot, click it.
That is for one particular.
Yeah, it's for one particular. In any case, it's one experiment.
For all the particular all the files like.
No, it will just be for one particular metric. So for that one metric, you have 64 ranks and is 64 threads of execution.
What I'm getting from this, like each there's a tag wall or the case file where the data compressed data for each case.
For each case.
Each run of the cluster, or
yeah, each one of them represents one unique run. So you have 16 is one trial, 8 cores is another trial.
Yeah, so within that database, you have a trial value, what do you call the characteristics times metric called time.
Yes.
That time you have to click and then you try to do analysis.
Exactly.
So that will do analysis all of the sets in the experiment scaling, or
no, just one. It will do it for only one. So it will then look at the time with, for example, I'm doing the correlation results. So I'm looking at the correlation results for 16 core, 16 MPI rank case with 4 threads. So only for that, I'm looking at time and then seeing how all the 64 of those threads map out for pairs of events, 2 at a time. So these are the results that I can see 2 at a time and see how they are like this result. Okay, this is the same thread, sorry. If I look at this one, you can see this is minus 0.22, which shows how the threads are correlating for the pairs of events. And you can see it's still doing 72 out of 100. So it's trying to get all of these results organized. This is with BinV, RHS, and so on. So I showed in this particular example that here, this is a correlation result where I can see that the value is nearly -1. That means with MPI barrier and calc cut box contributions, they are inversely related. As the value of one increases over ranks, the value of the other decreases. And we had seen such negative correlation even with our demo.ppk, where we saw there were 2 functions that were inversely related to each other. One was concave, one was convex. So this is just an example of 2 negatively correlated events that we can capture with PerfExplorer. So I'll just suggest that you try this analysis, look at this visualization charts for a single metric, and is a normal probability plot. And if you are trying to look at these other canned charts over here, then you should click on this experiment scaling. Here is a 3D correlation cube for the top 4 events in PerfExplorer. And you can see the names of these events and how they are correlated to each other. And the color scale. So the key takeaway is you can create the profile data sets with tau, and then you can upload them to the performance database. And then you can launch tools like ParaProf and PerfExplorer that can then do the analysis. You can even launch them together at the same time, and they can access the database without any contention. And here is the trial, and you can see this in ParaProf. So if I double click on this, it will load this time metric, and I'll be able to use my regular ParaProf views as well. And you can see the bar plot and such. So my goal here is to allow you to try and use these tools with a simple example. And once you have tried these tools yourself, it will help you as we apply these tools to more complex cases. So any questions about what I've just shown with ParaProf and PerfExplorer before we move on? Are there any questions online? Did the PerfExplorer views work? I'll just give a few seconds and allow everybody to catch up with this. Again, CD to this demo data tau directory on AWS, then delete this whole paraprof folder, upload.sh, PerfExplorer, create the, open up the tabs, then launch PerfExplorer, and you can see the time metric here, and then do analysis and choose between these clustering or correlation analysis. Look at the visualization tab and pick some of these options and just get familiar with this tool. So I'll just give a few minutes for you to try this yourself.
PerfExplorer is kind of useful when you want to present results. That's so that for basic user who want to provide, I think ParaProf is enough to see
what's happening in a single experiment. But the moment you want to run analysis with multiple core counts of the same application and you want to study scalability, then PerfExplorer is relevant. So for a single data set, you're right, ParaProf is sufficient to see the analysis of what's going on in one thread. But PerfExplorer does some automated extraction of knowledge more than what ParaProf can do. ParaProf is just showing you as a profile browser what happened.
Yeah.
So with I think I kind of understand the answer, but I'm just going to ask the question anyway. If I have a code and I want to scale this thing up, I need to start running PerfExplorer on the serial, on the single-threaded.
Absolutely. Yeah. You want to understand.
I got, because to make this thing, to really make this thing run well, I got to make sure I have a really good serial. So is that I have a really good serial model with no bugs in it, and that I can understand what it is I'm trying to find the hotspots and paralyze the hotspots, and then try to work through, hey, am I doing all these things right as I scale it out from 4 cores or 8 cores on my laptop or my test machine or my test virtual machine before I can, and then hope that I've done everything right with the right environment and everything to get it out to Satonics or to, whatever, when I want to go to 1,000 cores or 10,000 cores or 100,000 cores or hundreds of GPUs.
Yes, you're right.
Yeah.
So how easy, but just a general question, like how easy to install Tau system, like user if you want to run it on
Satonics and so it's easily available through SPAC, and you can just say SPAC install Tau. And then with the SPAC install Tau, we have recipes that are tailor-made, and you could turn on some variants of that. So you could say SPAC info Tau, and then see exactly what variants it provides, and then enable those. Like you could say plus Rockham or plus CUDA, and then it will install it based on that. Now E4S has a good installation of Tau, and I also have a separate installation of Tau on Satonics, and I'll go into that next with our hands-on session. But I'll describe how we can install Tau, how we can easily profile an application on a system like Satonics with that for various cases, serial or MPI related cases.
Unlike other profiling tools, it seems to be quite simple to run some commands.
Exactly.
Yeah. So it's quite interesting to see how users can adapt to it. It's quite straightforward compared to other profiling tools.
Yeah, because all you did is, say Tau exec and the name of the application without changing a binary at all. And if you can see details of not just the CPU tasks, but also the GPU execution, and it understands Rockham, it understands all of these runtimes, then it can be indeed very powerful for you to deploy in your, and it doesn't take much effort. You just run the same application with Tau exec with some options. So, are there some comments from our online participants? Were you able to do the PerfExplorer example with the clustering, correlation analysis? Yes. No troubles here. Great. And do you have any other comments about the use of Tau, or what problems you can foresee in integrating it with your workflows, or do you envision any issues in such integration?
Workflow. Here's your code, and you have things working. Let's start looking at what's actually happening in the code, and we start to fix things and then test it, and that becomes a cycle within that. But the hard part is
Absolutely.
the hard part is there's a lot of people who need it but don't know how to use it, or
yeah. So
and need to have better understanding of what their code actually does. They kind of have something that they either inherited or wrote, but not really developed themselves. So, but it's a thing. It's just a thing.
Absolutely, yeah. You're right. So I have some examples, even on Satonics, that we could look at. And in many cases, you can back up the profile files launch it either directly on Setonix, or you can go bring them the PPK file over to your AWS instance. You can just SCP it over there and launch the analysis tool over there if you'd like. So, but before I move on to Setonix, I just wanted to find out if there are any other issues with PerfExplorer that I should address, or if you need some more time before we move on.
Just a general question.
Yeah.
In terms of, you want to,
I think she's bringing you the mic, so they can also hear you. Question.
yeah. When you compile tau or when you install tau, so I try to run coloration or command on the system, but quite slow. So do we need, can we like use more cores to do the job on the tool itself?
More cores to do the job on the tool itself. That's a very good suggestion. Right now, we are serializing the analysis of the k-means clustering jobs and the correlation analysis. We can reduce the number of events by going to the dimension reduction, as I mentioned, and that can, of course, immediately speed up because you are just looking at events that are relevant. But doing the analysis in parallel is something we have not yet explored for the analysis tool, because we typically run it on the same desktop system.
Yeah, because if you are installing on a HPC, you obviously have resources which, when you SLOC, you'll have the resources on your hand, and then you can try to grab the resources for where you launch the.
And that's a good suggestion. We could parallelize our analysis tools, which are currently multi-threaded, but they are not launching on a GPU and doing analysis like that. While it could be beneficial to do but sometimes what happens is there are some center policies that say that you can run your analysis tool, but if it's doing MPI, it must go through the queue on the back end. And then it can get a little complex in just launching a tool and doing the MPI for the analysis tool. Right now, everything is just simple. It just works out of the box on the desktop or the login node with a single threaded case.
Yeah, just thinking widely.
Yeah.